Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi ta'ala wabarakatuh, and very good day to everyone who's watching this video. My name is Alif Akmal bin Omar, one of the final year student in Bachelor of Mechanical Engineering from University of John Malaysia. So today, I would like to share about my final year project entitled Energy Absorbing Characteristic of Cellular Core made of Kenaf-Based Composite. So when we are talking about composite, composite is materials that compose of two or more distinguished or different elements. Basically, in a composite, we also have a technology, we call it as a sandwich structure, which is currently being used because of a lot of advantages that we'll talk about this after this. Okay, so basically, back to the sandwich structure. Sandwich structure is constructed by attaching thin stiff face sheet, or we call it a skin, on the two sides of the low density material, or we call it as core, that constitute the panel. So in order to fabricate the sandwich structure, the material used is Kenaf fiber, in which reinforced with PLA. Why we use Kenaf instead of other plant? There is a lot of plants that have been used as a natural fiber for the sandwich structure. For example, we have flax, we have jute. But why we use Kenaf instead of the other natural fiber or the other plants? Because Kenaf is a biomass-based additive that also has recently gained a lot of interest for the researcher in the industry. Because Kenaf is substantially stronger capacity to fix carbon dioxide than other plant, or the other word we call it, Kenaf has photosynthesis rate at least 3 times faster compared to other plants. So in which that is very advantage to the sandwich structure because of the renewable resources that can researcher have to help in their research. Okay, so back to the sandwich structure, there is a lot of advantages of sandwich structure. For example, sandwich structure is very low density, also have higher energy absorption, and also shock resistant properties. Okay, talking about this project actually come from a few problems that researcher has experienced based on Kenaf itself, in which one of them is this structure have experienced major problem with durability, damage tolerance, and water intrusion. Other than that, using a core material with significantly low density, if I just mentioned just now that sandwich structure has low density, in which this is also one of the disadvantages or the problem nowadays, in which low density will reduce the stiffness and strength characteristic, which will increase the possibility of the complete failure of the composite sandwich structure. And other than that, the damage consequence of low velocity impact, for example, tool drops or high energy event, for example, ballistic penetration, is one of the problems that have been happened in the industry. And the last one, we would like to reduce the usage of synthetic fiber, because there is a lot of synthetic fiber that have been used in fabricating sandwich structure, which will cause higher emission of carbon dioxide, in which will result bad or environmental pollution to our environment. So we would like to change or to replace the synthetic fiber with natural fiber in order to have a green environment. Okay, so basically the objective of this project is to investigate the effect of cell height of honeycomb sandwich structure on compression properties, and also to investigate the effect of cell wall thickness of honeycomb sandwich structure on compression properties. Based on this objective, we have two parameters that will be controlled on fabricating the sandwich structure. First one is effect of the cell height. The second one is effect of cell wall thickness. Okay. As you can see, here is the process of the methodology in fabricating sandwich structure. Starting from the fabrication of skin and core composite panel using hot press machine, in which we use a stacking sequence technique in order to arrange the Kenaf with the PLA by 3 layers and also 5 layers. After that, we will have to press it with hot press machine After that, after fabricating the core, we will control the cell height, which 20 millimeter, 30 millimeter, and also 40 millimeter. And also, after having the sample will be tested using compression testing or flat wire testing with the loading rate of 2 millimeter per minute or 50 millimeter per minute. Okay. Talking about the result and discussion that I got from the study itself, so you can see there is three parameters that are measured. The first one is cell height, second one cell wall thickness, and also displacement rate. Based on the graph or the analysis of the graph, you can see the cell height, the increasing cell height will cause the higher energy absorption or specific energy absorption. That same goes for the cell wall thickness on the displacement rate. So basically, when we are increasing or we are raising the cell wall thickness and also cell height of the sample, will cause the higher energy absorption of the sandwich structure itself. Why is very important to have a high energy absorption in sandwich structure? Because of its benefit or expected benefit to industry. Okay, there is two main industry that are expected to use Kenaf or sandwich structure as support mechanism, support material. As the beginning, I think it's not that going to be a main material that being used in the industry, but I think the support mechanism, so that research by research we can see how far the sandwich structure using Kenaf can bring benefit to the industry. There is two industry that will benefit most. The first one is automotive, in which we use the high ionization capacity of sandwich structure as a car bumper and to reduce impact when frontal crash of car and also protect occupants from injury. Also in automotive, sandwich structure also can be used as an energy absorber in cladding structure for blast resistant. Other than automotive industry, we also use sandwich structure in aerospace because of the properties of Kenaf, in which is lightweight and also good energy absorption. We use it at the application on aircraft radome, the front part of the aeroplane, in which it will protect from bird strike. As we all know that when aircraft being on the sky, there is a lot of bird, and also there is a possibility, high possibility on the bird strike of the nose radome structure of the aircraft. So because of the good energy absorption, sandwich structure is expected to improve or to protect the radome from the bird strike. Other than that, through the aerospace application also, we can use Kenaf or we can use a sandwich structure as the internal floor of the aircraft because of the high energy absorption that can withstand high compressive load of passenger. Okay, as you can see on the design discussion, compression, the compressive strength or the compressive load, one of the compressive load, highest compressive load that sandwich structure can hold is almost 100 kilonewton. It's a huge amount of compressive load that sandwich structure can hold or withstand. So basically, it's a very good application that we can use in automotive and aerospace industry because of first lightweight, because of the lightweight of the sandwich structure, and also the second one is because of the high energy absorption of the sandwich structure. Before I come to the conclusion, in project there is a lot of type or there is a lot of structure of sandwich structure, which for example we have square core sandwich structure, we have corrugated core sandwich structure, and also in this project we use to have honeycomb core sandwich structure, one of the structure that been used for this project. Okay, so in conclusion, the higher the number of the higher the number of layer or cell wall thickness will improve the compressive strength, or also we call it a specific energy absorption of the sandwich structure. And also, the increasing in cell height will give higher value of compressive strength, also specific energy absorption. And also, there is a slight improvement when we raising the displacement rate when having the compression testing to the compressive strength and specific energy absorption of the sandwich structure. Basically, that is all about the project that I currently working on during the 2 semester on my final year, about the energy absorbing characteristic of Kenaf-based composite using sandwich structure, or more specifically, I use honeycomb core sandwich structure. I think that's all from me. Hopefully, my sharing will give a lot of benefit to the one who hear my video. Also, I do hope that the research on Kenaf as a natural fiber and also research on sandwich structure will keep going on to improve. The first one, to replace the synthetic fiber. Natural fiber is very important to replace synthetic fiber for our environment, and also to have one of the technology that will be improved in terms of high energy absorption while retaining the lightweight of the material. It's very important to have lightweight material and also high energy absorption in a lot of industry. I do hope that you guys will have something about my project. That's all from me. Thank you.